today. So chemistry, let's talk about the first chapter in the chemistry. We are going to discuss with some basic concepts of chemistry. Some basic concepts of chemistry. So what all you are going to require in chemistry? Some basic concepts of chemistry. So in this chapter there are multiple things that you are supposed to know. The first thing that you are supposed to know is what is chemistry, right? So the chemistry, you know what is chemistry. You know what chemistry is. We are studying about different compounds, how different compounds are made up of, what is present in different compounds, right? So in this chapter you also have what is atomic structure, what is atomic number basically. So what is atomic number, what is mass number. So basically you have seen, for example, hydrogen is there in the periodic table. Hydrogen is represented. How do you represent hydrogen? Hydrogen has an atomic number of 1 and its mass is also 1. So basically it has 1 proton. Hydrogen has 1 proton and it does not have any neutrons. That's why it has mass number also 1. Let's talk about um, so this is the basic concept. Okay, so there are elements which have atomic mass and atomic number. So mass number, for example, we represent an element like this. Here we write its atomic number, whatever is its atomic number, and here we are going to write its mass number. What is its mass number? It can be represented by Z also. It is generally represented by Z. So this is the concept. A means number of protons that are present, number of proton, and Z means number of proton plus neutron. Now what is this neutron? Let me just brush up things to you. You must know all these things by now, but let me just tell you. So in the middle we have nucleus in the atom, which contains, these are my protons. For example, what I'm drawing right now, these are my protons which are present in the middle of the nucleus. Along with these protons, there are certain other elements which are holding these protons. Those are called as neutrons. Those are called as neutrons. Those are called as neutrons. For example, here you are able to see there are 3 neutrons. And outside that, the person revolving is known as electron. Outside it, the electrons are revolving. So there are multiple electrons revolving around it. So this is how the atom looks like. So number of electrons here will be 4 because it is a neutral atom. It has 4 protons which are positively charged. In green color I showed you. So this is known as number of proton, and these are known as my neutrons. So this element has 3 neutrons and 4 protons, and since it is neutral, it will have 4 electrons as well. So generally we don't represent the number of electrons. See here you don't see anywhere electron number written, because number of proton is only number of electron unless it is charged atom. So that is why we don't mention that. Okay, so now how will you find how many neutrons are present, because this number is telling both proton and neutron. So if you do Z minus A, so basically if you are going to do Z minus A, then you will get number of neutron, right? You are going to get number of neutrons. So that is a simple concept, very simple concept. Now let's talk about laws. There are different types of laws of chemical combination. In chemistry, you are going to study about different laws of chemical composition. There are a lot of questions asked from this. Laws of chemical composition. So laws of chemical composition, here you have multiple laws. The first law is law of conservation of mass. Law of conservation. Law of conservation of mass. Conservation of mass. So mass is basically conserved whenever you see any reaction. For example, 2H2 plus O2 gives rise to H2O. 2H2O, right? So 2H2 plus O2 gives rise to 2H2O. So here basically if you see 4 gram of 4 gram of hydrogen is reacting with 32 gram of water to give rise to 36 gram of water, right? So if you combine both these masses, the mass that we had on the left hand side, the same mass is present on the right hand side. That is the meaning of law of chemical, law of conservation of mass. That is the first law. Then we are going to study about the law of definite proportion. This law talks with respect to proportion. Here 2 is to 1 is the ratio, right? H2O, when you see here, 2 is to 1. So 2 atoms of hydrogen are joining with 1 atom of oxygen to give rise to H2. So that is water. Water is always H2O, right? Water means water is having a definite proportion, which is nothing but H2O. 2 atoms of hydrogen and 1 atom of oxygen, or nothing but, basically if you talk about, it is going to have a mass of 2 gram plus 16 gram, which is nothing but 18 gram. Water is always going to be 18 gram wherever you see, and water is having proportion 2 is to 16 gram ratio, which is nothing but 1 is to 8. 1 gram of hydrogen is always going to react with 8 gram of oxygen. So that is what is water, right? So this is known as law of definite proportion. Then we have law of multiple proportion. Law of multiple proportion. Here nothing. There are different types of compounds which are formed. For example, H2O, and there is also H2O2. So all these, when you take the ratio, they give simple ratio. For example, here ratio is 2 is to 1. Here the ratio is 2 is to 2, which is nothing but 1 is to 1 if you simplify it. So they are always reacting in simple ratio. If you take this hydrogen constant, we are focusing on this hydrogen. In both the places, hydrogen is 2 atoms of hydrogen. 2 atoms of hydrogen can react with 1 atom of oxygen, or it can react with 2 atoms of oxygen. So these ratios are going to be always simple when you take their ratio. That is the meaning of law of multiple proportion. Now the most important topic in this chapter that we are going to start with, this is the topic that you must know. That is mole concept. So the questions are going to be coming from this only, mainly the questions are from this mole concept from this chapter. Mole concept and stoichiometry are the most important topics that you must know. So what is a mole basically? So when you talk about what is a mole, so mole is nothing but 6.022 into 10 to the power 23 atoms or molecules or ions. When it is in multiple of this number, then it is called as a mole. This number is also known as Avogadro number. Okay, that is the meaning of a mole. So this much number of anything if you have, that is called as a mole. Just like 12. If you have 12 bananas, that is called as a dozen, right? If you have 12 bananas, when you go to shop, BANANA, 12 bananas, that is known as a dozen. If I ask 2 dozen, how much you will get? 2 into 12, which is nothing but 24 bananas. So that is the meaning of 2 dozen. So dozen basically here represents 12. Same way, for us, mole is nothing but Na, which is nothing but 6.022 into 10 power 23. This much number of anything is called as a mole. So it's very simple, right? So if I want to find how many moles, how many dozens I have, then what do I do? If I want to find how much mole I have, if I tell you a number, suppose I told you 12 into 10 power 23. That means 2 mole, right? 6 into 2 is 12, 12.4044 approximately. So that is the meaning. So if I give you a number, suppose I have some number of, suppose I tell you I have this much number of something. So if I give you a number and then if I tell you to find moles, what do? You are going to divide with Avogadro number, which is 6.022 into 10 power 23 Avogadro number. Or if I give you mole and if I tell you to find number, then it's very easy. 2 mole means how much? 2 into 6.022. 3 mole means how much? 3 into 6.022. So when you multiply the mole with Avogadro number, you are going to get the total number of atoms that are present. Now there is also based on weight. There is also based on weight. We can also convert weight to mole or mole to weight. That is done by, how do you do it? Weight. So weight, if you want to convert to mole, just divide by the substance molecular weight. In periodic table, the molecular weight of every compound is given. If you divide the molecular weight, for example, water's molecular weight, if you try to find the water's molecular weight, it is 80, right? So 36 gram of water means how much mole? Divide this 36 by 18, the mass of water, which is nothing but 2. So you are going to get gram also anyways gets cancelled. So 2 mole of water we have. This is how we convert it, okay? So this is the process. And reverse is also true. If you multiply it with molecular weight, you can convert mole to weight. And then how do you convert mole to volume? To convert mole to volume, you are supposed to multiply it with, and how do you convert volume to mole? Okay, these are the two things that are possible. So volume, if you want to convert volume into mole, you are going to multiply with mole into volume, you are going to multiply with 22.4 liter, 22.4 liter, or divide by 22.4 liter the volume, you are going to get the mole. So this is the concept, because 1 mole of any gas is equal to 22.4 liter, and whatever is the molecular weight of any substance, that is called as a mole. That's why when you multiply with the molecular weight any mole, you can get the weight of the compound. Okay, so that is the entire concept of mole calculation. This is the mole concept. It's a very simple concept. When you do lot of questions from it, you will be very clear with it. Now let's talk about percentage composition. What is this percentage composition? Percentage composition. What is percentage composition? Percentage composition of any element is nothing but, so percentage composition is nothing but whatever is the atomic weight of any substance, atomic weight of element that is present, if you multiply it with number of atoms that are present, and if you divide that by whole molecular weight, if you divide it by molecular weight, and then if you multiply it with 100, that is known as percentage composition. For example, let's try a question here, basic question. Again, I will be doing H2O only the example. So I want to find the percentage composition of hydrogen. So how do you find? Atomic weight of hydrogen is how much? Atomic weight of hydrogen here is 2 gram. 2 gram of hydrogen is present. Atomic weight of hydrogen is 1 gram. There are 2 atoms, so 1 into 2 divided by molecular weight of water is how much? Molecular weight of water is 18 into 100. So how much do you get? From here we get 2 by 18, which is nothing but 1 by 9 into 100. solve this, you get 100 divided by 9, which is nothing but 9 ones are 9, then again 9 ones are 9, again 0.111, so you get 1.11.111%. So this is the concept. So this is the final answer. 11.11% is water. H, hydrogen, percentage of hydrogen. Similarly, you can find the percentage of oxygen also, percentage composition of oxygen. So this is the entire method of doing percentage composition. Next, let's study about what is density. Let's study about what is density. So density, there are two things that you must know. One is absolute density. Let's talk about density. Density means it can either be absolute density or it can be relative density. Relative density. So for solid and liquid we use absolute density. For solid and liquid. So for solid and liquid, absolute density is basically nothing but absolute density is mass by volume. Mass by volume. For gas also it is same thing. So density is equal to mass by volume for gases, but there is an extra formula. For gases you can also use this formula. For gases you can also use D is equal to Pm divided by RT. So P is pressure and M is the molar mass, R is a constant, you know that, and T is the temperature. So this is the formula for gases. R is universal gas constant. Now let's solve it. So mass by volume, you know, density unit is gram per, density unit of density is gram per ml, and here it is gram per liter when you solve from there. Okay, so that is the entire concept. And what is relative density? Relative density is nothing but density of, if you take the density of substance and if you divide it by density of water at 4 degrees Celsius, density of water at 4 degrees Celsius, this is known as relative density. It does not have a unit. It is a unitless quantity because both are density, are dividing two densities. So then how will it have a unit? So density of a substance, density of substance and density of water is nothing but at 4 degrees Celsius, if you see, it's nothing but 1 gram per centimeter cube. This is the entire formula of there is also one more thing which is known as vapor density. Vapor density. So vapor density is nothing but vapor density is equal to mass, molecular mass of any gas if you take and divide it by 2. It's not actually 2. Here we write 2 because molar mass of H2, hydrogen gas. So if you take the molar mass of any gas and if you divide it by the molar mass of hydrogen gas, which is nothing but 2, so then you get the vapor density. So this is the formula of vapor density. So hope all of you are clear until now, whatever we learned. These are the very important topics in this chapter, that is some basic concepts of chemistry. Now we are going to learn about average atomic weight and mean molar mass. There are some topics left over. So average atomic weight and mean molar mass. So first let's discuss about average atomic weight. Let's discuss about average atomic weight. So what is the average atomic weight? Average atomic weight. Average atomic weight is nothing but the percentage abundance. You know the percentage abundance, how much a compound is present. It is used for isotopes basically, okay? For mainly for isotopes, how much percentage an isotope is present they will give you. So percentage abundance of any isotope into atomic weight of that isotope. Percentage abundance of first isotope plus percentage abundance of second into atomic weight of second plus percentage abundance of third compound into atomic weight of third compound. So this is how you keep going on, okay, how much ever compounds are present, and divide it by 100. This is known as average atomic weight. So it is used for basically isotopes. Next, there is also a thing, for example, if you want to see, let me tell you a small short example, just to make you more clear with the concept. For example, you have chlorine 35, Cl35 is an isotope which is present 75%, okay, chlorine 35 is present 75%, chlorine 37 is present 25%, and chlorine. So these are the two atomic weights, and we are supposed to find the average atomic weight. What is the average atomic weight? So how will you do it? So basically you are going to take percentage abundance of first compound. So percentage abundance here is 75% and 35 is the mass. So multiply 75 into 30. 75 into 35 plus 25 into 37. 25 into 37 is the next one, divided by 100. So when you do this, you will get 35.5. This is known as the average atomic weight. So this is how you find the average atomic weight. Now let's see the next concept. Mean molar mass. Mean molar mass. Now what is this mean molar mass? If there are multiple gases, then we find the mean molar mass. What is mean molar mass? Mean molar mass is nothing but you take the number of moles of 1 and multiply it with mass of 1 plus number of moles of 2, multiply it with mass of 2 plus number of moles of 3, multiply it with 3, divide by number of moles in total, whatever gas is present. So this is known as mean molar mass, and these are nothing but total weights only. We take the total masses, how much a gas is present, and we are going to divide it by number of moles, okay. So that is the meaning. So for example, let's see a simple question. O2 is 16, O2 is present, mole percentage 16%, nitrogen is present 80%, carbon dioxide is present 3%, SO2 is present 1%. So find the mean molar mass. So what you are going to do, basically you are going to multiply 16 into molecular mass of this one, which is 32, plus 80 into 28 is nitrogen, plus 3 into 44 is carbon dioxide's mass. SO2 is 64. So 1 into 64 you are going to multiply, and you are going to add all these. Now total is 100% because total percentage is 100 here. So you get 29.48 is the final answer. This is known as mean molar mass. So next let's talk about limiting reagent. This is a very important topic. All of you must understand this. This is where the stoichiometry is going to start. So stoichiometry, you must know about what is limiting reagent. You are going to solve questions by taking, because always see, we don't always have a compound which is sufficient. See, when suppose I told you a reaction, 4 gram of hydrogen is required, 4 gram basically, okay. For example, 4 gram of hydrogen is required to react with 16 gram of 32 gram of 32 gram of oxygen to give rise to 36 gram of water, right? Now suppose, do you always think you will have 4 gram of water, hydrogen? Suppose hydrogen is less than 4 gram. Then do you think 36 gram of water will be formed? Because to form 36 gram of water, you require 4 gram of hydrogen. But if 4 gram of hydrogen gas is not present, if 4 gram of hydrogen gas is not present, then 36 gram of water will not be present. Less than 36 gram of water will be present, because 32 gram of oxygen needs minimum 4 gram of hydrogen to react with it. If hydrogen is less than 4 gram, then this oxygen will not be completely able to react. All the oxygen cannot react, right? See, suppose I have one oxygen atom. This one oxygen atom is going to eat one hydrogen atom, for example. Okay, one oxygen atom is going to eat one hydrogen atom. If hydrogen atom is less than 1, then do you think this will be able to eat something? No, right? So same way, whatever mass of hydrogen is required by this 4 gram of, whatever mass of hydrogen is required by this 32 gram of oxygen, that should be present. Otherwise it will not be able to form the same amount of compound. Same thing for hydrogen. 4 gram of hydrogen needs 32 gram of oxygen. If 4 gram of hydrogen is present but 32 gram of oxygen is not present, then oxygen becomes a limiting reagent. It is limiting the reaction. Because of that, 36 gram of hydrogen will not be present, right? So how do you find now which one is the limiting reagent? So let's see. So you understood what is a limiting reagent, right? So limiting reagent means the reagent which is limiting the reaction, okay, which is not allowing the entire compound to be formed, which is present in shortage. So that is called as limiting reagent. That is limiting reagent, or reactant also sometimes. Reactant. So how do you do it? So suppose I will tell a simple reaction. Suppose A needs 2 moles of B to form 3 moles of C. Okay, but and right now I have 3 moles of A with me and 9 moles of B with me. So find the how many moles of this will be present. Now how do you find first who is the limiting reagent? See, the first step that you are supposed to do is divide how much moles you have with how much moles are required. Divide how much moles you have. I have 3 moles and here the coefficient of A is 1. So divide both of them, okay? So what do I do here? 3 divided by 1. Here what will it become? Here it's going to be 9 divided by 2. Correct? So it's going to be, because we have 9 moles and we required 2 moles for the reaction. So 9 by 2. Now which number is small? This 3 by 1 gives me, this 3 by 1 is nothing but 3. 9 by 2 is nothing but 4.5. Now which of the two numbers is small? 3 is small, right? 4.5 is bigger. So 3 is small. So 3 is called as my limiting reagent. So 3 becomes my limiting reagent. So 3 is my limiting reagent, Lr. Okay. So whatever 3 can react with, how much ever moles of B 3 can react with, that much only it will be able to react. The remaining will be excess. Correct? So 1 mole of, let's see what else we are able to do, what we are able to understand. 1 mole of A could react with 2 moles of B, right? So 3 moles of A will will react with how many moles of B? 1 with 2, then 3 with 6, right? 6 moles of B. Then we'll be able to react with 6 moles of B. But right now, how much do I have? 9 moles I have. So 9 minus 6 gives me 3. So 3 moles are extra. 3 moles of B will be excess. That's how you find excess reagent. That is known as excess reagent. And how much mole of this will be present? C will be produced. How many moles of C will be produced? So we have only 1 mole of A. 1 mole of A gives 3 moles of C. So 3 moles of A will give 9 moles of C, right? 3 3s are 9. 9 moles of C. That's how you find how many moles of product are produced. 9 moles of the product will be produced. This is known as limiting reagent. They are going to ask you questions like this. So doing this, you can solve everything, right? I almost explained you everything. You can convert the moles to this one, volume of the gas. You can convert, once you know mole, you can convert anything. You can convert to mass and you can find the mass of the compound that is present. So this is the entire concept. In stoichiometry, you require balanced chemical reaction. So you must know how to balance the chemical equation if you are doing stoichiometry. So next let's discuss about empirical and molecular formula. Empirical and molecular formula. See, empirical formula is nothing but the simplest formula. For example, suppose we have C3H6 compound. This is our compound, C3H6. So what is the simplest ratio? Carbon is 3 and hydrogen is 6. If you take simplest ratio of both of these, 3 2s are 6, right? So you get 1 by 2, which is nothing but 1:2. So if you write it in simplest ratio, you get CH2, right? You get CH2. This CH2 is known as our empirical formula. The CH2, if I multiply the CH2 with some number n, that will give me the molecular formula. Molecular formula is the exact formula. Molecular formula. So n is what here? You can clearly see here, n is nothing but 3. If I multiply it with 3, then I will get the final formula, right? So CH2 into 3, this 3 is known as n. So what do I get? C3H6 when I multiply both the numbers. So this is how we get the molecular formula. So empirical formula multiplied with n. Empirical formula multiplied with this n gives me the molecular formula. This is the entire concept of this. Then you also have concentration terms, which I will be discussing in solutions chapter. So this is the end of the chapter. Hope all of you understood whatever I explained to you until now. So thank you very much. Subscribe to the channel and stay connected. I will definitely share the questions to you if you are interested. If you are messaging in the comment section, I will share the questions only to the people who are really interested in. Okay, so thank you very much. Subscribe to the channel because we will be covering all the chapters, revision videos just like this. Then just short videos, everything that's important for you to crack.